In this video, we're going to talk about how to round numbers in chemistry after you do a calculation. The first set of rules goes with multiplying and dividing. So let's say that you are trying to calculate the density of a particular object or a compound, and you find that 12.37 grams of this material takes up a volume of 8.2 milliliters. Now your scale is pretty awesome, and it can get down to that hundredths place for its measurements. But when you're measuring your volume, you only have a regular old 10 milliliter graduated cylinder. So you could only see that 0.2 line because you had one of those ones that only has 5 tick marks in between each milliliter. Okay, so we have our values that we got in lab. When you punch these numbers into a calculator, you end up getting some absurd number, like 1.508536585 grams per milliliter. Well, no one in their right mind would believe that you would have this much accuracy in a high school chemistry lab, or a college chemistry lab even. So we have to round. We have 2 sig figs on this bottom number and 4 sig figs on the top number. The way it goes with multiplying and dividing is that you have to keep the fewest amount of significant figures. It helps you report your results from your calculations in a much more honest and accurate way. This means that we need to have 2 digits in our answer. So what I'm going to do is I'm going to write down these 2 digits, but I have to check the digit next to my last one to see if I need to round up or down. 0 is less than 5, so I'm going to keep that guy just the way it is, and I would report my answer as 1.5 grams per milliliter. The second set of rules is for adding and subtracting. When you add and subtract quantities, you really just keep the fewest amount of decimal places. Let's say that you had a really big graduated cylinder and you had to measure 105 milliliters. The largeness of this cylinder made it really difficult to tell how many milliliters you actually had, so you only had this many decimal places. Let's say you then added 43.7 milliliters from a better measuring device, where you could tell what the tenths place digit could be. When you add these up, you end up with a number that looks like 148.7 milliliters. Now I can't keep all of these digits because one of my measurements does not have an accurate guess for that last spot. So I'm going to have to chop this number right where I am missing digits. Okay, so I'm going to definitely keep the 140 part, but I need to check and see if I need to round up this 8. The number next to the 8 is a 7, which is bigger than 5, so I'm going to report this as 149 instead. So my answer for this calculation in chemistry would be 149 milliliters. That's basically all you need to know about sig fig rounding for all of chemistry until we get to acids and bases.